I was asked to talk about another way to produce energy. And why did we do this? Why did we actually start thinking about the production of energy in some other way? And I guess there were initially three reasons. One is that we had a lot of wet manure at Ranges Valley. Those of you that have been to Ranges Valley would know that unlike, say, a Downs feedlot, or if you're in the United States, a Central Valley or a Panhandle, or a lot of those areas that are drier areas, we're high in the hills. We're 1,000+ metres above sea level, and if it gets wet in the winter, it's seriously ugly. And I know there's someone here from Charlton who would have some empathy with that view. So that was one of the first things that came into our mind as to what can we do about that? How can we handle that wet manure? The second issue for us was regarding cost. The previous managing director of Ranges Valley, Malcolm Foster, obviously did a better job than me, but it was about $180,000 a year in, I think if I go back a few years, in electricity and gas. Today it's $800,000 a year in electricity and gas to run our business. And that cost is just killing us all. I know that I'm sure I can see a few nodding heads around that understand that issue. The second was one of the things that that both speakers have talked a little bit about, and that's branding and just simply being seen to be doing the right thing. And I mentioned, I think probably yesterday, but we've got customers in some countries around the world who ask us to tick certain boxes before they'll even talk to us about our beef. So they say, we want to understand your safety, we want to understand what you're doing in welfare, and we want to understand what your environmental activities are. And when we tick those boxes, we'll then consider whether we buy your product. That's not all customers, but that sort of thing is not unusual. The other thing that happened to me was I visited a JAPFA feedlot, and I saw the boys all pop their head up when I mentioned the company name. And welcome to everybody from Indonesia, from the JAPFA company, and we're very pleased to see you all here. I visited one of their feedlots just out of Bandar Lampung in Sumatra, and they have a biogas facility which was built in conjunction, I think, with Cargill. I'm guessing here, but I think that's correct. So that was the first one that I'd seen actually on a feedlot site, and that's been there for quite a few years. So I thought, here's an opportunity. Let's see what we can do about it. So the initial thought was, let's turn it into electricity, and that was, I guess, the logical thing to consider. And we met with a company from Europe. We met a lot of companies. As soon as you start to talk about this, every person in the planet seems to be a biogas specialist, and they knock on your door. But we engaged with an organisation called MT Energy that are based in Zeven in Germany. And they have a representative based here in Australia, in fact lives in Tamworth. And we talked to them about what they do. They have over 1,000 sites in Europe, and they're mainly in the dairies and piggeries. And one of the pluses that they've got, which is similar to the JAPFA site, is that they can wash fresh manure off a concrete pad into a biodigester every day. And by doing that, you get 100% of the viable solids, or 100% of the energy that's in that manure is available to you, which is significantly different from a feedlot operation like ours, where you've got manure in a pen, which I'll talk a little bit about. The other thing that those operations do in Europe is they usually utilise things other than manure, particularly silage, and in one case where I visited, they were also growing turnips, and they were being thrown in the mix as well. When we started this process, we didn't do it on the basis that we'd get massive subsidies, or in terms of the capital cost, or we'd get subsidies for production. We wanted to try and make this thing work on its own, and we're in the process of assessing that actually works. And of course we are examining all the available options for government to make a contribution as well. So what did we do next? So we looked at, as I said, a number of partners, and we chose MT Energy. So we wanted to develop from a thought to an assessment, to a feasibility study, and then on to integration and implementation. And that's the phase we're sort of currently in at the moment. MT Energy were a logical choice for us. They're very experienced, as I said, with over 1,000 sites across Europe. They have great engineering expertise. They do all their own testing. They manufacture a lot of the equipment. They repair and replace equipment as well. So they're quite an integrated organisation. One negative was that they've had no direct experience using dry manure. So that was something that is a challenge for them and a challenge for us in determining the viability of the operation. I visited, as I've said, their plant in Zeven, and for them the production of new sites in Europe is probably topping out. So almost every dairy and piggery has one. So they're looking around the world to find the next opportunity for where their technology can be used. And the places that they're going is Australia, the United States, and also into China and other parts of Asia. So the specific issues for Ranges Valley. One, we have two lots of manure. We have wet manure and dry manure. And the dry manure in a pen, and FSA are doing a lot of work in this area, as is MLA. But you end up with about 50% of the viable solids, or about half the energy that's available in about 7 days. So it drops very quickly, and once you get to 7 days, then that stays reasonably stable at that level of energy availability. The other issue we have is that we've moved into using wood chips in a lot of our pens, and Gareth will, I think, probably talk about that today. And those wood chips are making an enormous difference to our business. I won't steal his thunder, but it's an important part of what we're doing. The negative to that is that you've got nice fresh manure and you've now stuffed it all full of wood chips. And I can tell you, wood chips are not a great thing in a biodigester. So we then had to try to work through how we could take that manure and make it suitable for putting into a great big biodigester, which is about half the size of that building. Because our product, unlike coming off a concrete pad, it's got rocks in it, it's got dirt in it, it's got wood chips, and it really is quite an issue as to how you manage it. So we're looking at designing a sort of a tumbler system so that we can actually wash the manure away from all the other products. To put manure into a biodigester, it needs to go in as a liquid product, about like pumpkin soup, I suppose you'd say. So the best way to do it is to use an effluent, which has also got energy in it. You wash the manure out. We'd like to recycle the wood chips, which is part of the process we're designing. So you get to use the wood chips twice, take the rocks and dirt away. Some of the dirt will still end up in there, but at least you've taken all the big chunky bits out. We also considered about accessing the grid, and I know that's one of the challenges for us, and particularly where we're located, but accessing it and getting paid a reasonable price is somewhat problematic. So in this particular instance, so we're actually looking at it. We probably will access the grid, but it's not a key part of what we're going to do. So how are we going to utilise the energy that we produce? When you put manure in a biodigester and you produce methane, you've then got to turn that methane into various forms of energy. And in our case, the gas itself, we're looking to utilise, and I'll talk about that. Secondly is the production of electricity using generators. And thirdly, and most importantly, is that you've got to use the heat. So when you have motors that are running, that are producing an enormous amount of heat around the turbos and around the exhaust, to make this work in a dollars and cents sense, is you've got to be able to utilise that heat. And I'll talk about how we can do that. The second part of one of the issues is at the end, unlike today where and you'll see it at Kerwee, where you've got a nice product that you can compost, you can turn it, you can stick it in a truck, you can put it in a bag if you're like the McConaughey family do. We end up with that same pumpkin soup at the end, and you've got to work out how to manage that. Now there's different ways of doing that. Storing it in a ground facility, you can spread it, that's not a problem, but we don't have customers that want to use it every day, so you've got to have a storage system to manage it. So the current position for us is that MT Energy have been on site with engineers. They've done a lot of desktop work examining our electricity usage. And the problem, which I know Gibbo mentioned it as well, the difficulty you've got in a feedlot is that the peaks and troughs in usage are enormous. So trying to manage that and have a generation system that can cope with that is one of the challenges that we've got. They're working out how we can use the gas and also how we can access the grid. They're trying to, at the moment, develop an integration model that will in fact replace our current LPG boiler. It'll be replaced with a methane diesel boiler. So you have methane with a diesel backup. And the generation system is likely to be 2 motors. So you'll have one motor that will be like a base load motor, and then you'll have a second one that will provide those peak times when you start the mill up and all the activities that come from that. The other is, how do we use the heat? There's a number of things that we can do. And the most obvious is that you boil water with it. So what we would then do is that water would be used to temper grain. So our tempering system would be using hot water instead of a cold water. And the other logical one, of course, is that you preheat your boiler water before you go in. The second stage of this plan is that we would actually dry the digestate, as we call it, the product that comes out the bottom. You can dry it, you can bag it, you can in fact turn it into a high quality fertiliser product. You can put other components into it. You can put nitrogen back in or whatever you'd like to do, and then you've got a really saleable product at the end. The phosphorus and potassium, which are the 2 main components from a fertiliser perspective that are in manure, you retain virtually all of that in the digestate, so you don't lose it in the production of methane. So in effect, the current value of the manure is retained from a fertiliser perspective. The only issue is that it's, instead of being something nice you can lift up and throw in the back of a truck, you've got to pump it, which is all a bit ugly. So with regard to the gas, you need to turn the methane that comes out of the top of the facility, you need to push it through a membrane and clean it, and it then goes into what they call biomethane, and then you've got a product that you can compress, and it's then good enough that you can use it in feed trucks and loaders. Our understanding is that that product, which is produced at a very low pressure, you can pressurise it enough so that in a course of a day a feed truck may have to reload, refuel maybe once, but in feed trucks and loaders, of course, are driving up and down past your facility all the time. So the ability to do that is there, unlike a motor vehicle that's travelling away from the source of the energy. So I said the electricity part of it, the plan is to have 2 motors, so I said base load, peak load, and then access to the grid. What's it actually look like? As I said, it's not quite as big as that shed, but probably half as big and about the same height or a little less. There would be 2 of them. They have an outer cover over the top and then an inner membrane that floats up and down. And the pressure of the methane is around about 1 to 2 bar or 1 to 2 atmospheres, so not a high pressure product. Then you have a burn-off, excess burn-off, which of course you try and avoid. The methane product then flows from there some distance. They like it to go a reasonable distance so that you can get rid of the moisture, so that you can get rid of the moisture out of that gas so that it's more usable. And as I said, it goes through the cleaning membrane at the other end. Then you've got a product that is able to be stored. And the 2 motors will of course provide the electricity and the heat. The way the system also works is that you have an automatic loading system. So you have a big box, a bit like a batch box, and you keep feeding that batch box, and it's an automatic system. So it's an automatic feed system for manure and whatever product you like to use. You need to use some of the heat that you generate to maintain the temperature inside the digester. I think at around about 40 plus degrees. So there's a certain amount of heat used in that process as well. When we started this, it looked pretty simple. I thought this would be wouldn't be hard, and you'd get it off the shelf, and they'd all know all the rules, and it'd be quite easy. But because we're using a product that is very different from what is used throughout the world, and it's dirty and it's got all the other issues associated with it, it's turned into somewhat more difficult. But we're committed to it. We've contracted to this company to go through this next stage, which will provide us with a full integration model. It's fully, all the costs and things are done. The payback on this at this point in time is reasonably quick. The cost per kilowatt will be good, is our understanding at the moment. We need to test this up a little bit more, but at this point in time, we look like being able to remove something like an $800,000 cost from our business to do perhaps add more value to our manure than is available simply selling it, and also tick a few other boxes with regard to environment and our brands. So maybe not for everybody, but I'm certain that this will be a part of what we do in the future. As I said, it's just normal business in Europe. It's just what everybody does, but it's made a lot easier, of course, because you can wash fresh manure off a concrete pad, and it's a much simpler system. So thank you very much. I hope that's sort of given you some idea of what we're trying to achieve, and you'll be welcome to come and have a look when we get it built. So thank you very much.